From martial arts mastering combat robots to dancing humanoids learning entirely through simulation, and an $8,000 open-source robot that's making tech giants take notice, we're no longer talking about incremental progress. We're watching the birth of a new era where machines don't just assist us, they're starting to move, fight, and think like us. The rise of combat-ready humanoids. Let me paint you a picture that would have seemed like pure science fiction just 5 years ago. In China, Unitree Robotics has announced the world's first humanoid robot fighting competition, dubbed the Mech Combat Arena, scheduled for May to June 2025. But this isn't some distant fantasy. We're talking about real robots, real combat, and real-time human control that's about to be broadcast nationwide through China media, through platforms. The star of this unprecedented event is Unitree's G1 humanoid robot, and what this machine can do will make your jaw drop. Standing at just 1.32 meters tall and weighing 35 kilograms, the G1 has been caught on camera performing complex martial arts moves that would impress any human fighter. We're talking 7-7 20-degree spinning kicks executed with precision, rapid recovery maneuvers after being knocked down, and combat stances that demonstrate a level of balance and coordination that seemed impossible for machines just a few years ago. But here's where it gets really interesting and slightly unsettling. The G1's combat abilities aren't just programmed routines. Unitree's advanced algorithms enable the robot to learn any move anytime, suggesting these machines are continuously evolving their fighting capabilities. The practical applications extend far beyond entertainment, as martial arts training helps robots develop better balance, quicker reactions to external forces, and more natural movement patterns that could be crucial for everything from emergency response to industrial applications. What's particularly striking about the G1's capabilities is how they've been developed. Using motion capture training systems and NVIDIA's Isaac simulator, the robot has learned professional-level performance through virtual training before ever stepping into a physical arena. This simulation-to-reality approach is becoming the gold standard for robot training, allowing machines to practice thousands of scenarios without the risk of physical damage or the time constraints of real-world training. The implications for society are staggering. When robots can learn martial arts, they're not just gaining combat skills, they're developing the kind of dynamic balance, spatial awareness, and quick decision-making that could make them invaluable in dangerous professions like search and rescue, law enforcement, or military applications. But it also raises questions that we're just beginning to grapple with. What happens when our mechanical creations become physically capable of defending themselves? While Unitree was teaching robots to fight, Tesla was taking a completely different but equally revolutionary approach with their Optimus humanoid robot. In a series of videos that sent shockwaves through the robotics community, Optimus demonstrated something that might seem trivial at first glance, but represents a massive leap in robotic capabilities. It learned to dance. Now, before you dismiss this as a marketing stunt, let me explain why this development has robotics engineers around the world rethinking what's possible. The dance moves you saw weren't pre-programmed routines. Every step, every arm movement, every subtle shift in balance was learned through reinforcement learning and simulation, and then transferred to the physical robot. This represents a fundamental breakthrough in how robots learn and adapt to physical tasks. Milan Kovac from Tesla's Optimus AI team emphasized that the entire routine was trained using simulation-to-reality reinforcement learning, with numerous optimizations already implemented for the sim-to-real training pipeline. What makes this particularly impressive is that Optimus performed these dance sequences both with and without safety cables, demonstrating true autonomous balance and movement control. The dancing demonstration showcases several critical technological achievements that extend far beyond entertainment. First, it proves that robots can now learn complex, coordinated movements through virtual training and successfully translate them to real-world performance. Second, it demonstrates dynamic balance capabilities that are essential for any robot working in human environments. And third, it shows that these learning systems can rapidly iterate and improve. Tesla's team mentioned that many optimizations and fixes were already in place for future training. But here's what should really capture your attention. Murtaza Dalal, another member of the Optimus AI team, pointed out that Sim2 Real RL is the key to getting next-level agile dynamic motions. It's also the key to precision and robustness. This isn't just about making robots dance. It's about creating the foundational technology that will allow robots to perform any physical task that humans can do, potentially with greater precision and consistency. The speed of development is equally impressive. Tesla demonstrated clear progression from cautious movements with safety cables to confident, untethered dancing in a matter of days. This rapid iteration cycle suggests that once these learning systems are in place, the pace of capability development could accelerate exponentially. The $8,000 game changer. Just when we thought the week couldn't get more revolutionary, K-Scale Labs dropped what might be the most significant bombshell of all: a fully functional, open-source humanoid robot for just $8,000. To put this in perspective, most humanoid robots currently cost more than luxury cars, with some systems priced in the hundreds of thousands of dollars. K-Scale Labs just democratized an entire industry overnight. This isn't some toy or limited prototype we're talking about. We're looking at a 5-foot-tall humanoid robot called Stompy that walks, learns, and interacts in real-world environments. The fact that both OpenAI and NVIDIA have taken notice tells you everything you need to know about the significance of this development. When the biggest names in AI are paying attention to a garage startup, you know something revolutionary is happening. K-Scale Labs accomplished something that seemed impossible. They built a complete humanoid robotics stack in just 5 months. This includes open-source hardware designs, reinforcement learning models, vision language action models, and a simulation-to-reality operating system that anyone can use to build and train their own humanoid robot. The implications of this open-source approach cannot be overstated. Think about what happened when personal computers became affordable in the 1980s, or when smartphones reached mass market pricing in the 2000s. We're potentially looking at a similar inflection point for robotics. When the barrier to entry drops from hundreds of thousands to under $10,000, suddenly universities, small businesses, hobbyists, and entrepreneurs around the world can start experimenting with humanoid robotics. The robot features some impressive specifications for its price point. Built with carbon fiber pad and designed so each part fits on a standard 256 by 256 3D printer bed, Stompy represents a completely new approach to robot manufacturing. The quasi-direct drive actuators with 6:1 to 8:1 reduction ratios ensure all joints are low inertia and back-drivable, with torque values ranging from 3 to 12 Newton meters. A hot swappable 48-volt 15-amp-hour battery pack provides over an hour of operation. But here's what makes this really special. K-Scale Labs isn't just selling robots, they're building an ecosystem. Their reinforcement learning library and sim-to-real pipeline allow anyone to train policies for humanoid robots in less than 5 minutes. They've even created a benchmark system where you can train a model and send it to them to run on one of their robots, democratizing not just robot ownership, but robot development itself. While these 3 developments captured most of the headlines, they're part of a broader wave of innovation that's reshaping the entire robotics landscape. Agabot's Lingji X2 has been demonstrating remarkable balance, agility, and intelligence, including the ability to recover autonomously from falls, a skill that remains rare among humanoid robots. The robot operates almost silently, addressing one of the key barriers to robot integration in human environments. What's particularly impressive about the Lingji X2 is its integration of the G1 general-purpose AI model, enabling vision-based perception and planning that allows the robot to understand its environment and respond to human gestures or voice commands. This zero-shot learning capability means the robot doesn't need pre-programmed tasks. It can infer actions from context, a foundational requirement for any general-purpose humanoid. Singapore-based Sharpa has unveiled the Sharpa Wave, a 22-degree of freedom robotic hand that's setting new benchmarks in manipulation. With over 1,000 tactile pixels per fingertip and pressure sensitivity of just 0.005 newtons, combined with the ability to deliver 20 newtons of force, this hand represents the kind of dexterous manipulation that will be essential for robots working alongside humans. Figure A, AI's latest demonstration of their Figure 02. Robots showcased remarkable dynamic stability. maintaining balance even when subjected to violent physical disturbances. This kind of robustness is crucial for robots operating in unpredictable real-world environments where unexpected interactions are inevitable. What's enabling all these advances isn't just better robots, it's better infrastructure for robot development. NVIDIA's announcement of 2 powerful blueprints for synthetic data generation represents a fundamental shift in how robots learn. Isaac Grout Mimic uses high-fidelity physics engines to amplify real human motion data in simulated environments, while Groot Dreams generates entirely new motion sequences from single-input images using generative AI. This infrastructure development is crucial because it solves one of robotics' biggest challenges: the lack of large, diverse data sets for training. Unlike computer vision or natural language processing, which can leverage massive internet-scale datasets, robotics has been limited by the difficulty and expense of collecting real-world interaction data. These new simulation and generation tools are changing that equation fundamentally. The simulation-to-reality pipeline that multiple companies are now using represents a paradigm shift in robot development. Instead of tedious real-world training that risks hardware damage and requires enormous amounts of time, robots can now learn in accelerated virtual environments and transfer that knowledge to physical systems. This approach is not just faster and safer, it's enabling entirely new kinds of learning that would be impossible with traditional methods. If you want to stay ahead of these rapidly evolving developments and understand how they'll impact your industry, your career, and your life, make sure to subscribe and hit that notification bell. The pace of change in robotics and AI is accelerating, and the next breakthrough could happen tomorrow. Don't get left behind in the most important technological revolution of our lifetime.